Okay guys, let's start with the solutions then. Okay, so we were continuing, we'll be discussing ABCD in this one. So I'll give a brief explanation of each of them. So in this problem, they have said we need to find the number of occurrences of ZO in E, where E is small. So it's just a brute force solution where we just take the substring, current substring, and from ith position till 4 characters, and then if it's equal to the required one, then we increase the answer count. The required string is over here, and then print the answer. So that's it. Yep. So the next problem is, okay, so in this problem what they had explained is that, so there is a tower of height h and height 1000, this is of height 1000, and then there is an UFO of height h, which is, I guess, always less than or equal to 1000. Yeah, so it could be anywhere like over here. So this is height h, and then it's at a distance capital D from the tower, and then we have some obstacles here, like say this point, these are obstacles. So each of them will be having coordinate di and hi. And then we need to find the minimum distance a person has to climb up in the tower, such that he can clearly see this UFO which is over here. So if he draws a straight line, there must be no obstacle blocking it. So what is that minimum height that he needs to climb up to in the tower? So that was the question. So the idea behind this one is that the obstacle which has the lowest slope with this UFO, that will require the most height in the building to be visible, to make the UFO visible. For example, this is one of the obstacles, say, and sorry. So this is the slope it makes with the UFO, and suppose here we have another obstacle, this one more obstacle, and this is the slope it makes with the UFO. If we extend this line, right, so we can observe that the obstacle which makes a lesser slope with the UFO will be requiring more height over here than the one which has like more slope. So among all the obstacles, we need to find the obstacle which has the least slope with the UFO. So that's the idea, and we need to then find the y-intercept of that. Find the slope and then find the y-intercept. At least that is the way I did it, and it worked as well. So we just input all the obstacles, and initially they're given the D and H, the vertical distance and the horizontal distance and the vertical distance of the UFO. And then here we are using comparator function where we are sorting based on the slopes. So after this sorting is done, the first one will be having the lowest slope, least slope, and then for that point we find the slope with the UFO, and then find the y-intercept. And one more edge case is like if the y-intercept is less than 0, then the minimum distance will be obviously 0, right? So we need to ensure that the minimum distance is 0 and then print the answer with the precision whatever they have specified. So that is about problem B. Let us see if there is any alternate solution for this thing. Okay, so instead of sorting, they have just directly calculated the y-intercept. Yeah, that is better actually. It reduces the complexity from O of n log n to O of n. Yep, even that can be done. Yeah, so okay guys, so let's start with problem C. So here it says that like there are n rows and 5 columns, and like we need to select exactly 3 rows from n of them, and we need to minimize the maximum of all the columns. For example, if there are n rows, we need to select exactly 3 rows, and then each of the columns, from each of the columns we need to select the maximum of those columns respectively, and our goal is to maximize the minimum. So for this problem there exists one brute force approach, which is O of n cube time complexity, but the problem with that is because of the constraints, like it will not fit in the time limit. So another approach exists, like whenever we have to optimize the solution from initial guess value to the answer value, we can use binary search approach, where we have to like maximize the minimum or any of those optimization things. So but here we need to apply binary search on a 2D array. So let's look at it, how we can apply binary search on a 2D array. So here we input the matrix n cross 5, and so here we start with so the answer will lie between 0 and 10 power 9, and we start with the mid value as in binary search. So we calculate the mid value, we pass it to a function. So the function will determine if the condition is satisfied or not, and then based on the condition we change the start or the end value. Okay, so now we look at what is the condition that the function is trying to verify. So the function will select three rows, and then we'll check if there are 3 rows such that the minimum of all the 5 maximums is greater than the mid value. So this the condition is trying to verify. So what does it imply? So it implies that there are already 3 rows that have the minimum greater than the mid value. So this mid value is a potential candidate for the answer, but still can we still maximize it further? So to check that, we assign start is equal to mid. So it means mid is also satisfying value, but to check if there is any better value other than mid, we are increasing the start value to mid, so that the next mid will be higher than this. And if the condition is not satisfying, that means that mid is too high already, and then we need to reduce the mid. So that's why we are decrementing it to m minus 1. Minus 1 here because mid is not satisfying, and there is no point in again keeping it as m, so m minus 1. So the function in itself is like this. So we are iterating over the columns of all rows, and for all the columns we are assigning a bit. Think of it as 5 spaces, where each space is for each column, and it will be 1 if the corresponding aij is greater than mid, then we are setting it to 1, otherwise we are setting it to 0. So like that we do it for all of the 5 columns for all the rows. So initially bit will be 0. Say suppose the condition is satisfied, then it will become 0 0 0 0 0 1. Now in the next iteration we need to make space for the next check, so we left shift it by 1. So this is the left shift operation for this. and in the next one we can check like if the condition is satisfied or not. So that cycle continues for all the columns and all the rows, columns of all the rows, and we insert the for that column, for that row we insert the bit to the collection, to our collection. So now we have a collection where we have collection for all the columns, for all the rows, sorry. And now to determine, so how do we determine if this condition is satisfied or not? So if all the 5 set bits are 1, then we can determine, yeah, so we have all the maximums which are greater than the mid value. So the minimum among all the maximums must also be greater than the mid value. So that is how we verify all the 5 must be set. So here we are iterating thrice because we need to select 3 rows, and we do an XOR operation. Like for example, let's take this example. Like suppose these are the bits of the 3 rows. Here, like as you can see, none of the row has all the bits set completely. But when we do XOR of all the 3, then we can see that we get all set bits only when you do XOR of all these 3. So what that means is like it still satisfies the condition despite none of the rows individually have all the bits set. So it may happen that more than one row may have the same bit set, but it does not do any harm. Like it's not a disadvantage anyway. So we just check if the XOR is like 31. 31 is because 2 power 5 is 32 minus 1. So that shows all the 5 bits are set. And then, so if all the 5 bits are set, then we return 1, otherwise we return 0. And then, so that is how we converge to the most optimal answer. So that was it about problem C. Now we'll go to problem D. Yeah, so in problem D what we are given is, so we are given a string like this, and whenever we meet with a capital R over here, so whenever there is a capital R, we need to reverse the already inputted part. Like for example, when we meet R over here, we have ABC already there, so we need to reverse that part, and then we append CJ, and then again R comes, so we need to reverse ABC, CJ entirely. So we need to do this operation, we need to do this operation every time we meet a new R. And then after that we need to remove, after all the R's are processed, from the final string we need to remove 2 consecutive characters everywhere, like wherever it's present in the string. So here the approach what I followed is, here we can observe that this after the last R, the remaining part of the string never gets executed, so we need not process it. So I am reducing the search space to this part where we meet the last R. So this line of code is doing that. If end is less than 0, in the sense like if there is no capital R, then we can just remove the duplicates and print. So that's an edge case. Otherwise, I am following this approach where I am splitting this substrings based on the R values, like based on the intervals of R. So ABC is one substring, CJ is one substring. I am separately processing them and putting them in a vector of strings. So this part of code will do that. And then there's something more we need to do. Internally we need to check if the characters internally would get reversed or not. So for that we need to check like how many times R is processed for the substring. For example, for ABC, R is processed only once. So internally also it will get reversed, the characters. It becomes CBA internally. But for CJ, it was the reverse. For ABC, R is processed twice. So internally the characters, it remains the same, the format. It doesn't get reversed. But for CJ, after CJ, R appears only once. So that is odd number of times. So it becomes JC later. So depending on the count, whether it's odd or even, I am just reversing the individual substrings as well. So now we'll see how we can arrange the individual substrings in the proper manner. Okay, so here we can see AF only gets reversed once, so it occupies the first position, and AE would get reversed twice, so it occupies the last position. So similarly, we need to alternate between first and last, so it becomes AF, AE, AD, AC, AB, AA. So I'm just starting from the last position and decrementing by 2. So for example, AF comes first, and then go 2 places left, AD, and then next AD comes, and then further go 2 places left, AB comes. So in that order I am inputting, I am putting in the resulting string. And finally, for removing the duplicates, we can make use of the stack. So if we process the stack from the back, it becomes, that's the right way to do it, to process the stack from the back. So initially it's A only, stack contains A, and then B, and then when we are at this first character, second character, we just check if the stack top is equal to the current character, which is true. So the stack top is B, which is equal to the current character. So that time we pop the topmost character, and we just go to the left again. So over here as well, again the stack top equal to the current character, so we pop it, and in this case the resulting string is null only. If something character, like if some C was there over here, then it would have been again that thing. So this is the way to do it: process from the back and check if stack top equal to the current. If yes, then pop it, otherwise we can just process it. So this is how we can solve it. And so, like, thanks for watching the video, guys. So if there are any improvements, please write in the comments below, and yes, thanks for watching.